All right, let's do an example for this one. So, according to the American Red Cross, 7% of people in the United States have blood type O negative. Ooh, that's what we're looking for there. So, a simple random sample of size 4 is obtained, and the number of people X of O type blood negative is type O negative. Oh my, is recorded. Construct a probability distribution for this. Okay, so this has two options. You can either have O negative blood type or not. That's what makes this binomial, right? So you have these two options. Okay, and we are sampling 4 people, so we have a fixed number of trials that we're looking at, and each one is independent because we're talking about different people. So we are good, right? And everybody has the same opportunity. So as I'm looking at this, the first, second, third, and fourth, that's where these 4 trials come in because it's a sample size 4. The first person could have O negative, so could the second, so could the third, so could the fourth, right? Or the first person could have O negative, but then the second one could not, or vice versa, right? So each time I have a trial, I have success or failure, O negative or not. And then based on that, I could have the first person doesn't have O negative, but the second person does, right? Third person doesn't, next one does. So all of these options are available. That is what the tree diagram is for here in step 1. Now, I'm not going to have you actually draw out a tree diagram. I just want you to see what that looks like. All right. Okay. So we construct this tree diagram, and then we're going to look at my values. So with a binomial, we have the probability of success. Oh my gosh, you guys, I can't even read that. I don't know how you guys handle my handwriting. I appreciate you. Can I just say that? Success. Oof. Hang with me. I appreciate you. I really, really do. Now remember, probability is between 0 and 1, so that's a percent. Can I write that as a percent? No. How do we write it? As a decimal, so 0.07, because to change a percent to a decimal, you move it twice. What's the probability of failure? 0.93. Good, because that's the complement, right? And remember, success in this particular problem is designated as you have type O negative blood, or you don't, and that's failure, right? It's not saying what type of blood do you have, right? Like, what is your blood type? No. Specifically, O negative, yes or not, right? That's how we get that success and failure. Now, what are my possible values between these 4 people that we're checking out? Could any of them have it? Yep, none. Just 1 person, 2 people, 3 people, or 4 people, right? So that is how we're laid out here with these outcomes. All right. Okay, so now we've got it. Now let's compute these probabilities. All right. And we're going to round to 5 decimal places. So the first one is I'm going to have the probability here that 0 people have O negative, right? And that is this last option down here. The probability that it all fails, right? The probability that it is fail, right? The probability of 0. I just want you to see what this looks like. I'm not going to write this out for all of them, but just so you can see what's happening here. Okay, so when I'm multiplying these 4 together, right, because that's what we're doing is multiplying these 4 together, I have all fails, 0 successes, that's what this means, and all fails. So fail here in my book is a 0.93. So 0.93 4 times, and that's that exponent. And we're going to take it to 5 decimal places, so plug that in your calculator, and what do you get? 0.74805. Yep, me too. All right. What's the probability that just 1 is successful? Now notice, I'm just going to rock it for this one just so you can see what it is. This is 1 success. Where do we see that? There's 1 success. There's 1 success. There's 1 success. There's 1 success, right? So I have these options, the number of successes here, 1 success, 1 success, 1 success, 1 success, that we're looking back through, right? Here's the 0 success. Do you see what? So I like to have this tree diagram on there just for visual so you can see what's going on. But there's all different options for the 1 success. So I'm not going to write this part of it because it could be fail, 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 safe, success, right? Fail, fail, success, fail. So it doesn't matter which person I talk to, simply that one of them works, right? Okay, so if I'm looking back through these problems, I can have these 4 different options. So of my 4 different options that I'm looking at, right? 1, 2, 3, 4. 4 different options are available to me that we're going for, okay? Then I'm going to say 4 times I have 3 failures and 1 success. So 0.93 3 times and 0.07 1 time. We don't put an exponent of 1 just because we understand that to be the case. Do you see what just happened there? Okay. All right, so let's do it. If I take 4 times, because there's 4 of those, 0.93 cubed, 0.07, what do you get? 0.22522 is what I get. Are you agreeing? Nice. Okay, let me change my color up because I think that's getting to be a lot. The probability of 2 are happening. Right? So 2. Do you see all these that are going down there? Now here's the deal. Whenever I have this, how many options do we have? 6, right? 6 times I am going to have 2 fails and 2 successes because I only have 4 options, right? I can have failures or successes because I have 4 sample size of 4. Oh, you're yelling at me and I hear you. Good job. I put that 3 up there. I don't know why I did. 2. So it could be 2 failures and 2 successes. That's my total of sample size 4, right? But I have 6 options that are going to get that job done in different capacities, but still 6 options. Okay, so then you plug that into your calculator and what do you get? 0.02543. Nice. Nice. Now what about 3? Let's try green here. 3. How many are there? 1, 2, 3, 4 options for 3, right? Okay, so I have 4 where I have 3 successes and I have 1, that should be a 9, failure of my 4 people. Do you see how this is playing out? Okay, so then plug that into your handy dandy calculator and what do you get? 0.00128. Nice, me too. Check it and let's make sure we're on the same page here. Now, what if I have the probability of all 4 people that I'm talking to are going to have O negative blood type? How many options are available for that? Just that one. Okay. And if I'm looking at this, I have 0.07 to the 4th. Just like I had 1 option here, all 4 of my options went with failure. Now all 4 of my options are going with success because I have 4 successes. Plug that into your handy dandy calculator and what do you get? And this is why we do 5 decimal places, right? 4 zeros and a 2 because that's a real small number. Nice. That way it's not just a 0. Now it could be all zeros in there, but that's what we have. Okay. Now we're going to present these values in a table. So 0 would be 0.74805. 1 would be 0.22522. 2 successes, meaning 2 of my 4 people are going to have O negative. 3 of my 4 people will have O negative. And all 4 of my people will have that O negative, right? That's what we're saying here. Now, how do I know that this is a probability distribution? What can you do here? Yes, add them up. If you add all those up, what are you going to get to? To 1, right? Or super close to that. As long as it's super close to 1, then you're still in good shape. Nice. And there's your distribution table. So we talked about it, and then that's how you play that out. Pretty cool, I think.